So, how do we get an AI to stop just, parroting things back at us and actually start to think? It's one of the single biggest puzzles in technology right now. And in this explainer, we're going to dive into exactly that, the pathways we're forging to teach AI how to reason, pulling from some key ideas in Stanford's deep reinforcement learning course. And really, this quote from that Stanford course just hits the nail on the head. We've got these incredible language models that can write things that look perfect, things that seem like they were written by an expert. But when you poke at them, you realize they're often just hollow. The logic just isn't there. And that's the fundamental problem we're trying to crack. So that's the big question, right? Why do these unbelievably powerful models fail in such bizarre, illogical ways? It can mimic Shakespeare flawlessly, but then completely flub a simple two-digit math problem. To figure that out, we have to look at how they learn in the first place. And the answer usually comes down to this: next token prediction. It's a classic training method. The AI is fed a truly massive amount of text from the internet, and its entire job is to get really, really good at predicting the very next word in any given sentence. Now, that's amazing for making it sound human, but it doesn't teach it logic. It just teaches it what a correct answer is supposed to look like. And we're kind of on the clock here. The estimates are that by 2028, we're literally going to run out of high-quality human-written text to train these models on. We're hitting a wall with the old method. We desperately need a new playbook, one that lets the AI generate its own correct data to learn from. So, how do we get there? Well, the big breakthrough came from a shift in perspective. We had to stop treating reasoning like a text problem and start treating it like a game. A game with a starting point, a series of moves, and, of course, a final score. And every game needs a rulebook, right? For that, we turn to something from reinforcement learning called a Markov decision process, or MDP. Don't let the name scare you. It's just a framework that gives our AI, our agent, a really clear goal. Take actions that get you the highest possible reward. It turns the AI from a writer into a player. And here's how it works in practice. Let's use a math problem. The state is just the problem itself. The action is the AI writing the next line of the solution. And the reward, super simple. You get 1 point if the final answer is right and 0 if it's wrong. All of a sudden, reasoning isn't about mimicking text anymore. It's about making winning moves. All right, so once we had this game framework, the first ideas for how to play it were pretty straightforward. The earliest approaches were all about one simple idea. Just find what works and copy it. First up, you've got the old standby, supervised fine-tuning, or SFT. You just show the model a bunch of perfect human-solved problems and tell it, do this. Then we got a little bit smarter with an approach called rejection fine-tuning, or RFT. Here, we let the model try to solve the problem a bunch of different ways. We throw out all the wrong answers, and then we train it on its own successful attempts. And this new way, RFT, it was a pretty big deal. I mean, it turned out to be twice as data efficient as the old method. But there was a catch. This clever little trick had a hidden and pretty serious flaw. And this is where it gets really tricky. What if the model just gets lucky? What if it stumbles into the right answer using completely nonsensical, flawed logic? Because with RFT, it doesn't matter. A win is a win. And the model would be taught to repeat that flawed path, reinforcing bad habits. So check out this classic example from the Stanford lecture that shows the problem perfectly. The model does a calculation, but then it immediately undoes it in the next step. The final answer still ends up being correct by sheer chance, so RFT would look at this whole mess and say, "Great job, do that again." So this right answer for the wrong reason problem, that's what led to the real breakthrough. To build a model that can actually reason, we had to go deeper. We couldn't just look at the final score. We had to teach the AI to become its own critic, evaluating every single move along the way. And the big idea, the key insight was this: forget about just rewarding the final answer. We have to be able to assign credit or blame to every single step in the thought process. Okay, but how in the world do you actually judge a single step in the middle of a long chain of reasoning? Well, the process is actually pretty genius. You pause the AI at a certain step. From that exact point, you have it generate a whole bunch of possible futures, or rollouts. Then you see how many of those futures end up with the right answer. That gives you the value of that step. A good step that leads to more wins gets a positive score. A bad step gets a negative one. And this is a total game changer, because now the AI can learn with so much more nuance.
It can look at a solution that failed and still say, hey, you know what? That first step was actually really good. I'm going to keep that. And just as important, it can look at a successful solution and find a lucky garbage step inside it and know to throw it out.
And the results? Well, they really speak for themselves. Remember how rejection fine-tuning gave us that nice 2x boost in data efficiency? Well, when you use a full-on reinforcement learning approach like this, with per-step rewards, you're talking about an incredible 8 times boost. The AI learns so much better, so much faster. Okay, so we've gone through all this theory, but what does it have to do with the crazy AI models we're all hearing about right now? Well, these pathways we just walked through, imitating, rejecting, and then critically evaluating, they are the absolute foundation for the powerful thinking models making headlines today. See, the big secret behind models like the new DeepSeek R1 isn't some brand new magical algorithm. It's actually the powerful combination of these sophisticated reinforcement learning techniques with bigger, more capable base models. So what do we mean by more capable? It means these new models can take more complex actions in our reasoning game. A modern AI can literally pause, check its own work, and then decide if it wants to continue. It can realize it's gone down a dead end, backtrack, and just try something else entirely. The moves it can make are just so much more strategic. So if you take one thing away from all of this, let it be this. There's been a massive shift in how we do things. We've moved way beyond just showing an AI what the right answer looks like. We are now actively teaching it the process of good reasoning by giving it the tools to critique its own chain of thought. And that leaves us with a really fascinating question to chew on. We started this journey just teaching AI to mimic text. Now we're teaching it how to reason. So as these models get better and better at genuinely thinking, what are the big challenges they're going to solve next? What problems that we thought were uniquely human aren't?